Problem 3-45. Rewrite each equation below. Then solve your new equation. Be sure to check your solution using the original equation. So problem A, we have the quantity of n plus 4 plus n times the quantity of n plus 2 plus n equals 0. So we want to rewrite our equation here. So what I'm going to look to do here is I'm going to look to just simplify it and rewrite it in a form that's a little bit more familiar. I look at the quantity of n plus 4, and because there's nothing being multiplied and it's not being subtracted from anything, I'm just going to leave it alone for right now. I look at my middle terms here. I have n times the quantity of n plus 2. I can simplify that here by distributing my n through. So what I have there is n times n is obviously going to be n squared, and n times 2 is going to give me a positive 2n. So that will become n squared plus 2n. I'm going to go ahead and bring down everything else in my equation because I haven't touched it. When I bring down my quantity of n plus 4, because nothing is happening to this quantity, I can go ahead and lose the parentheses. So I have n plus 4 plus n squared plus 2n plus n equals 0. Make sure you don't forget this is an equation. You can't just forget about the equals 0 part. Next, I can go ahead and combine my like terms. I know that I have an n here, I have two n's here, and I have an n here. So it'd be a total of 4 n's. So I have n squared plus 4n plus 4 equals 0. Now I've got that trinomial written here. I know it's quadratic and I have it set equal to 0. So the first thing I always want to check here is, does this factor? So as I look at n squared plus 4n plus 4 equals 0, I see here that this will factor. And whichever factoring method you prefer to use, go ahead and use it there. For time's sake on here, I'm just going to go ahead and do it the quicker way here. I know that I'm going to have an n plus 2 and an n plus 2 here. This is the quantity of n plus 2 times the quantity of n plus 2 equals 0. In which case there we know that one of our two factors has to equal 0 in order for the product to be 0. It's using the zero product property. Since my quantity is the same, I can go ahead and just solve for one of them. I have n plus 2 equals 0, so I'm going to figure out what would n have to be to make that factor 0, and I get n equals -2. So to check it here, they say that we should go back and plug it into our original equation all the way up here at the beginning. So let's go ahead and do that. We've got -2 plus 4, and then we've got plus a -2 times the quantity of -2 plus 2, then plus another -2, and that should equal 0. And let's simplify this and look and see what we get. -2 plus 4 is 2, plus we have -2 times the quantity of -2 plus 2. Well, we know that -2 plus 2 is going to be 0, so this is the same thing as saying -2 times 0, which we know the product of that would then end up being 0. And then we're going to add a -2. So +2 plus 0 plus -2 gives us 0. We get a true statement here, so we know that our work is correct there. Problem B. We've got the quotient of 4 divided by x equals x plus 3. So one way we can look to rewrite this is to go ahead and look to get rid of our denominator. So we need to figure out what we multiply by that would basically cancel out our x in our denominator. And we know if we take it and we multiply each side of the equation by an x, we're going to end up canceling out or getting 1 as a quotient there. So if I multiply this side of my equation by x and multiply this side of my equation by x times 4 is 4x. But then when we divide it by x, our x's cancel out, leaving us with 4. On the other side here, we're going to go ahead and distribute our x through. So we're going to do x times x and x times 3, which should give us x squared plus 3x. Our next step that we want to do here is we want to solve this. We know that we have an x squared term, and we have a 3x over here. So this is going to be quadratic. And remember, when we're solving quadratics, we want to get it so it equals 0. So we're going to have to subtract 4 from each side. And we're going to end up with 0 equals x squared plus 3x minus 4. Well, since it's quadratic, we want to check here if we can factor it first. There are no common factors besides 1 in each of our 3 terms. So I'm going to look to see here if this factors into 2 binomials. And it will. So let's see here. We're going to have factors of x squared. We've got x and x. Our factors of negative 4 that have a sum of positive 3 would be positive 4 and a negative 1. Positive 4 times negative 1 gives us negative 4. 4 times x is 4x. Negative 1 times x is negative x. A positive 4x and a negative x gives us that positive 3x. If you need to use your generic rectangle to factor it, please go ahead and do so. I'm just doing this shorter method here for the fact that I don't want it to take up too much time here in the video. Now we have the quantity of x plus 4 times the quantity of x minus 1 equals 0. So we're going to use the zero product property, because remember, when you multiply two numbers and you get the product to 0, then you know that one of the two factors here has to be 0. So let's take each one, set it equal to 0. We have x plus 4 equals 0, and we have x minus 1 equals 0. Solve each of those, and we get x equals negative 4, and we get x equals 1. So right now we're looking at, there are two possibilities for answers. Let's go ahead now and use our original equation to check it. So we'll start out here with the x equals negative 4 first. If I take my 4 and I divide it by negative 4, we're saying that should equal negative 4 plus 3. 4 divided by negative 4 is negative 1. Negative 4 plus 3 is negative 1. So obviously that works. Just moving my box over there. Now we've got x equals 1 for our second one. So let's see here. We have 4 divided by 1 should equal 1 plus 3. 4 divided by 1 is 4. And 1 plus 3 is 4. So since 4 equals 4, we know that that is correct there. So this would be your solutions for problem 3-45. If you have questions, please make sure you ask your teacher.